There's a big problem in the farming industry these days that not a lot of people think about, but it's worth billions of dollars. I mean, billions of dollars of losses, and farmers can't afford that. The more farmers that go out of business, the more fragile our food supply chain. Now, this is all preventable. This is all preventable using technology. Hi, my name is Gene Ligman. I'm an engineer. I have spent decades in vacuum applications. I currently own one business selling commercial industrial freeze drying equipment, which is a vacuum application. And while I was at a trade show, a gentleman from the grain industry approached me and asked me for a solution. It took me about a year of thinking, but I have developed some tech that is more than a step change difference in the technology offering. It's more than 10 times better. We'll talk about that in a little bit. About 7 years ago, I left Leibold Vacuum, one of the world's top vacuum equipment supply companies. I would say they're probably number 2 or 3 in the world. While I was with Leibold, I was one of their top industrial vacuum equipment sales development managers. I trained the sales force. I was that closer that they would send to a sale to close the sale, and often I would double the amount of the ticket while the customer would actually thank me for presenting things to them that they didn't even know. And when the equipment operated as expected, they were tickled pink. That's how sales of industrial equipment should operate. Because of that experience, I understand how production rate, reliability, and quality can make an enormous difference on the top and bottom line for people who produce things. I bring that mentality to my new company, Clear Grain. So this is actually my third company, but this is the first time that I'm seeking to make it into something big with a big team. So I'm going through all those steps right now. The equipment is in, let's call it, development phase. All of the physics is very simple. The machine itself is not very difficult. It is the combination of several different techniques that are already used in the grain industry and agriculture and food in general. But when you put them all together, it makes it over 50 times faster and can do a lot more as far as quality of the grain as an end product. Okay, so let me take you through my slide deck and we can show you a little bit more detail. So I'm calling my company Clear Grain Company, and the technology that I've developed I'm calling the VCO3. That stands for vacuum, carbon dioxide, and ozone. Those are two of the gases that are used in this process. We'll talk about that in a little bit. Why is this so good? Because it is a technology that I think will actually move the needle for farmers worldwide. This is actually a big deal. I've been in equipment industries for a long time, vacuum applications, decades, right? I'm 30 years plus, and I've never seen an application that's as exciting as this application is. The scope, the total addressable market, the impact that it can have on the world is just unbelievably good. So why? Well, it has zero residue grain protection, but it does it at industrial speed. Currently, the best practices are phosphine fumigation. It takes 7 to 10 days, and it's becoming less and less effective over time. It's chemical free. It uses only vacuum and atmospheric gases, as I mentioned, CO2, ozone, and nitrogen, all of which occur in the atmosphere. That doesn't mean that you don't have to be careful with them, because when you concentrate them, they can be hazardous. So you have to just handle it properly. You just have to scrub the exhaust and monitor it properly. This is easily handled by the technology. It does 100% pest kill in all 4 life cycle stages. This is super important. There are 2 stages that are particularly hard for current fumigation techniques to handle. One is the egg stage, because the weevils will encapsulate the egg into a sort of resin encapsulation that is very difficult for fumigation to get through. The other is the pupa stage, right, where it has gone, basically formed its little cocoon, and that happens inside the grain kernel. Difficult for most fumigation techniques to get to. That's exactly one of the reasons why this technology just completely outdoes everything else. This is a fast production process. It takes 2 to 3 hours instead of 7 to 10 days. That's more than a 50 times faster process. Now look, I've been in industrial equipment sales for a long time. There's one factor that affects your top and bottom line more than anything else, and that's production speed. To go up 10% in production speed in most industries is a no-brainer. It's a no-brainer for upgrade. To go up by a factor of 50 it's unbelievable. I have never seen an application that can have improvements of that magnitude. It results in long grain storage life because it's the final step is to lay it up in nitrogen. That prevents hot spots, which is a huge problem. We'll talk about that in a little bit. It prevents reinfestation by pests. It prevents reinfection by funguses and pathogens. And it does it all for free. And it will basically make grain that can be stored for years. And in certain places, right, in the grain belt in America, many of the large farmers will store their grain for years, hoping for a higher commodity price because the commodity price varies. They like to sell high and not sell low. The best way to do that is to store their grain through the low periods and then sell them when the commodity price goes much higher. And it does. This is the only technology that will address pests at 100% kill, but also will destroy mycotoxins that are already in the grain. We'll talk about which species are the most, let's call it, vexing to farmers and the grain supply chain on a future slide. It is the only technology that can recover already contaminated grain, leaving it smelling sweet. And we'll talk about the impact of bad smells in grain. It destroys odors like geosmin, a huge problem in the distilling industry, causes rejection of grain every single time. So there's other problems, right, that we should really talk about. So the tech right now is phosphine fumigation. As I mentioned, it takes 7 to 10 days, but there's another problem. The pests are becoming increasingly resistant to phosphine fumigation. And there are more and more countries who are rejecting phosphine fumigation as a usable fumigation technology because they have the perception that it causes health hazard problems. And I have heard stories from farmers who export that sometimes the phosphine fumigation is not quite cleaned up properly at the end, and it ends up going on the train or the truck with some phosphine pellets still intact. And when it gets to the customer, it causes big problems, big legal problems, especially when there's export involved. There is also about a 10% annual growth in organic grain demand. So having a technology that preserves that organic label, that has no input of any kind of chemistry, is a huge deal. Right now, there are millions of dollars lost to farmers and grain elevators due to rejections and, let's call it, lowering of the tier. You know, the grain gets rejected as human consumption or distilling, and then now it has to be sold as feed. There's a ding. There's a ding to the supplier that is a very, very painful ding. And I actually have some numbers in a future slide on that. 10 to 18% of all grain is lost annually to pests and pathogens. Humidity makes it even worse. But I have to tell you, 3 billion tons of grain is grown and shipped in worldwide every year. 3 billion tons, 10 to 18% of that is like 300 million tons plus of grain that is lost to pest and pathogen infection. When you multiply that times the amount of money per ton. We're talking billions of dollars of losses every year. And this is not affordable by farmers. They either have to pay for these expensive and not very effective phosphine treatments, or they have to accept lower prices for downgraded product or get rejected outright. And in certain industries, it's simply outright rejection. And then what does a farmer do? Well, then they have to go to a different mill or a different feed store that is selling it as feed. And even those mills, right? Even those feed mills have a problem with accepting grain that's got mycotoxin and weevil type infestation because their customers don't want it. They don't want to feed that to their horses. They don't want to feed it to their chickens. They don't want to see grain developing weevils. I know this because I've spoken to them about it. The bourbon industry. This is a big deal, right? So the bourbon industry consumes, if you will, uses most of the grain production of Kentucky, right? So all of our larger farmers like Langley Farms, Peterson Farms, Homestead Farms, Walnut Grove Farms, these are all supplying the bourbon industry with corn, with rye, with wheat. If they detect, and they can only do it by smelling it because the equipment to measure it isn't even sensitive enough to find something like geosmin, for example. If they detect any smell whatsoever, these distillers automatically reject. They have to, because the smells, these mycotoxins, right, that are produced, I mean, they're not really considered, geosmin isn't considered to be a toxin in that it makes you like unhealthy or it makes you sick, but it does make it makes the product have a bad aroma or just a slightly off aroma. That's a killer for your whiskey, your bourbon. You can't sell it. So I've heard stories about small distillers who have something like 1 to 3, sometimes even 5% of all their product that they can't sell, sitting around in barrels that they can't do anything with. They also have some certifications like identity preserved, right? Because the bourbon industry, all distilled industries, like every other industry, has certain quality standards that they can write their story around. And by treating the grain, by making it pristine, zero pests, zero toxins, zero smells, they can write the best story. It's organic, there's no chemicals, it's all residue free. Everything is better if it goes through the clear grain system. And it extends storage life. Now, it's not a big deal for the distillers themselves because the grain that they get generally only is on site for 3 days, be maximum, before it's already in the grinder and going into the mash. But for their suppliers, like Loretta Elevators or R&B Trucking, or any of these other regional elevators that supply the grain to the distillers, if the distillers can't get the grain or if they have to reject the grain, it causes a problem in the bulk of grain that they have to go through their system. It could cause a slight downturn in the amount of bourbon that they can get out the door in any given week. And money that you don't make this year is money you never make this year. The farmer benefit. These are all dings that the farmers have due to problems, right? These are the premiums that you get for premium products, non-GMO. I was just at Loretta Elevator a few days ago. They have a GMO testing right on site, right? It's a machine that can test GMO. Guess what? The clear grain process has nothing to do with GMO. Organic, this is all preserved by the VCO. Clean label, every single one of these premium product certifications are preserved with the VCO process because, again, it's just vacuum, carbon dioxide, ozone, and nitrogen, all of which go away completely. They lose money if they have pest infestations, right? You're talking 5 cents to 15 cents a bushel to the farmer or outright rejection. Mold and fungus, really bad. Sometimes it's 100% rejection, often nowadays. Odor, if you're trying to sell to the bourbon industry or any other distilling industry, it's dead. You got to sell it as feed. So you're going to get half as much for your product. and mycotoxins. It's a sliding scale because there's tests and it'll tell you how much it has. But frankly, the elevators are getting stricter and stricter with the farmers about what they will take. And furthermore, the safety risks, right? Phosphine gas there's services now that started up that come to farms with their phosphine pellets and their monitoring and regulations and all that sort of certifications. They'll come to these elevators or farms and do the phosphine fumigation, charge whatever service price that it is, and then go away, right? So all of these things are problems that are left behind by the farmer, right? Sometimes there's phosphine pellets left in the grain that they don't even know. They don't really have to use gas masks. The people that do the service do. But corrosion from phosphine, big problem. Big problem in steel or galvanized steel containers because phosphine is a really corrosive gas. It creates phosphoric acid. Sometimes you can have phosphine ignition. Phosphine is also a flammable gas. So what's the VCO3 solution? Well, I'm currently designing the VCO3 to be 100 ton per day processing unit, but I've got a feeling that I'm going to have a much smaller unit for smaller farms and smaller distilleries that just want to solve this problem on their own. And it's something that can be used as a pilot unit for the larger regional grain elevators like Loretta grain elevators, for example, just to test out the process and see how it goes. So essentially the product will go in the top of these vacuum chambers. There's automatic valves. Everything is PLC controlled. Vacuum pumps will draw a vacuum on the chamber when the grain is in there. And then it goes through a process cycling gases and removing with vacuum. So the exhaust from the vacuum pump will go through some kind of exhaust abatement to make sure that the CO2 and the ozone that's left in there is completely mitigated before it is emitted to the atmosphere. Plus you'll just have emission stacks. At the end of the day, all the gas that's left in process inside the grain is saturated with is nitrogen, and that is what gives you your ultimate passivation. So you have sweet smells, you have almost unlimited shelf life, you have high resistance to reinfestation by pests because there's no oxygen, you have low incidence or maybe completely no incidence of hot spot development in grain elevators for long-term storage. That's a big problem, by the way, because grain oxidizes and it's got microbes that will create heat. Now, usually in the center of the silo is where you have your problem because it's insulated by all the grain that's between it and the atmosphere, which might be cooler, especially in the wintertime. But grain is actually a pretty good insulator, so all the heat that's developed really starts to concentrate in the middle. You can actually have fires. But more importantly, it gets hot enough that it degrades the grain. Right? You have degradation of the starches. You have potential souring of the grain and development of things that you don't want in the grain. So if you can eliminate that, and you can by first sterilizing the grain and then laying it up in nitrogen, those problems will theoretically, this has to be tested, go away. It's just another benefit, right? So I was just down at Peterson Farms last week. I was speaking to Bernard. He said that, you really have to think about the pests, right? Because the silos that the grain is put in has a lot of crevices. This is where the pests hang out. They can just reinfest until it gets cold, right? Because the cold temperatures will really, let's call it, they'll really knock back the rate at which these pests can do anything. You're typically under 55 degrees Fahrenheit. The pests kind of go into dormancy. If it gets cold enough, they'll freeze, which will kill them. The interesting thing is, when the grain is in nitrogen and you don't have an oxygen bank there for the pests, they can't migrate in. They can't reinfest. So you might get some around the edges, but that's really easily mitigated, especially because that's going to be the coldest area in the wintertime. So phosphine is being currently used. That's the best in class. CO2 fumigation has also been tried, and it is effective. It just takes longer than phosphine and is maybe a little bit less reliable. Ozone has been used, right? So ozone treatment by itself has been used in Europe. It works, right? It's got lots of advantages, but ozone has a hard time penetrating through bulk grain beds. The reason is ozone is a very active gas. It will degrade into it'll react and degrade into oxygen very quickly. So it's very difficult to get complete ozone penetration through the entire bulk of the grain unless unless you draw vacuum first, and then the ozone penetrates very quickly and gets all the way even to the grain in the center. It has to, because the vacuum will draw it in. Even better is if you make a gas mixture that makes the insects susceptible, right? The reason that carbon dioxide is used is because it tricks these bugs into opening their spiracles. These are the vents that it respirates through. Not just in the adult stage, but also in the pupa stage and the larval stage, right? So once those spiracles are open, then the other gas, that being the ozone, can get in and destroy the insects very quickly. Ozone is a very, very effective sterilizer. It's used in water treatment facilities. It's used in sterilization facilities. It's used in sterilizing medical equipment and bandages and that sort of stuff. It's a very widely used sterilizing gas. One of the things that's great about it is that it degrades into pure oxygen, right? O3 reacts, produces O2. The oxygen is an issue for vacuum pumping. You have to be careful pumping oxygen because it can create fire hazards. But if you do it the right way, it will be fine. The VCO3 system, biggest thing is that it is 40 plus times faster in production. So I can get 100% kill in 2 to 3 hours. Has yet to be tested, has yet to be proven, but the calculations are very likely pretty dead on. It has 100% pest kill, zero chemical. It can actually rehabilitate grain, and it meets Probit 9 export standards. This is difficult. When you're exporting, you have to meet a higher standard of total kill. 99.996% of pests have to be eradicated. Essentially zero pests. It's like one occurrence of a pest in like a cubic meter or a ton of grain, which is not enough to cause a problem because it can't multiply. It will eliminate bad grain odors. This is a huge deal in bourbon. I've been finding out more and more about it, and it'll also destroy currently existing mycotoxins. So mycotoxins and other toxins are chemicals that are produced by the fungus or the bacteria that will continue being resident in whatever, even when you're cooking it, right? This is why sourdough still tastes like sourdough even after you baked it, because the lactic acids and the aromas created by the sourdough cultures remain, right? The actual biologics get killed, but the chemicals remain. This is what mycotoxins are, right? They are the residuals. They are degraded by ozone. So using ozone in this system with the vacuum cycling, this is actually, it's just something that keeps on giving. It's also a very low cost per ton way to operate. So you would expect this system that operates 50 times faster and does not just pest eradication, but mycotoxin and fungus eradication and bacterial eradication, and stops heating of the grain bulk. You'd expect this to be a much more expensive process, but it's actually less expensive because you can generate most of these gases on site right there with the in the machinery, right? So ozone, you simply put in oxygen and you get out ozone. You put it into a coronal discharge, you get out ozone. If you need to generate oxygen, you can do that with a compressor and a separation membrane. You get oxygen separated, you get nitrogen. So the nitrogen then is what you use for the next step, for laying up the grain afterwards, or maybe even passivating the bins that it's going to be going into, or even putting a nitrogen blanket on them for long-term storage. And the only other thing you need is carbon dioxide. You probably have to bring that in. It's cheap, it's easy, and it's widely commercially available. Other than that, you need power and perhaps cooling. More and more weevil populations are becoming resistant to phosphine fumigation. And then what do? It's the best in class. You go back to methyl bromide? I don't think so. It's being banned in most countries because it's a ozone depletion and greenhouse gas contributor. And of course, Here's a big problem, right? The egg barrier. Most of these fumigations are very poor at addressing this problem. The VCO3, that's one of the things that it's very, very good at. This is what a system would look like. We're talking about 6 feet-ish in diameter, 10 to 20 feet tall. That will depend on what size the industry decides it really wants, right? So I'm no Pollyanna, ego-driven person that thinks that whatever I develop is what they'll want. No, you listen to what the customer wants, you adapt, you pivot, you make it fit their need so that it gives them the maximum bang for their buck. That's what the VCO rapid cycle solution will deliver. So how am I going to get there? So right now I'm in the proof of concept phase. I am currently gathering the equipment to build a prototype. I will have this probably built by the end of June. I will start some samples. I already have some grain samples from a couple of distillers and one from Peterson Farms. We'll do some tests. This is just initial testing. The real testing is going to be done with a lab, right? So perhaps the University of Kentucky. There will be an actual scientific proof, right? Because you need to prove a process in order to A, get it through regulatory oversight, B, really convince the customer that what you're claiming is true, and C, provide some amount of track record that you can leverage in your sales stories and in your applications, and really have confidence that what you do is going to be good long term. I can see a time when, in the future, if a bag or bin of grain is stamped with the Clear Grain logo, processed by Clear Grain, that it will automatically have a higher selling price or a higher acceptance rate at end users like bourbon industry. So the pilot scale phase will be development of smaller units, pilot size units that will go to regional granaries, perhaps large farms, maybe even very small units that go into a distilling industry to see, or a distilling, let's call it a company, to see whether or not it would be a benefit to them. And then there's the commercial expansion. So the commercial expansion is going to be all about direct sales force. This is a direct sales force thing. You never put this kind of technology into the hands of reps. You need to show the customer how much money they can make with a system like this. So direct sales force and a supply chain, either creating a factory that builds these systems, which is the long-term goal, because we're talking about perhaps 1,000 of these systems per year. And by the way, you'll see when we look at the total addressable market that if Clear Grain were to build 1,000 of these systems per year, it would take 60 years to saturate the market if it became the standard that you had to use. So there's going to need to be a team, right? There will need to be sales, there will need to be manufacturing, and then there will need to be service. So all these things are part of the commercial expansion. This is the point at which venture capital would be most helpful. It would also be nice to have some capital influx during the pilot scale phase. Clear Grain is in the process of investigating grants, government grants, to pay for, to contribute most of the costs of this pilot scale phase. Clear Grain has found some really good partners at the University of Kentucky and their associates to leverage for getting these grants. So it's actually very likely. The targets of phase 1 is to prove it, right? To prove it with independent laboratory validation. The second phase is to either build something like a complete module that will do something like 100 tons per day, or maybe it's one that does 10 tons per day, or maybe 1 ton per day. That's for the customer to decide. That's part of what the customer discovery process, which Clear Grain is, which I am currently involved in, will reveal. The idea is to have a twin vessel architecture. So while one is soaking, the next is evacuating and doing gas injection. That makes the process one step closer to continuous production. I can see mechanical trickery where with a number of vessels you could actually achieve very close to continuous production, and at something like an export terminal where if you have a failed batch of grain that takes 7 to 10 days to be refumigated before you can load that cargo ship that you're paying $35,000 to $40,000 a day in drayage that's sitting in the harbor waiting to be loaded. If you can put the grain back through a system that is real time, continuous production, the ROI will be months instead of years. So what are the targets? The first target is the regional hubs. I've identified quite a number of them. We have value-added mills, which are less high priority, and people who are actually using the grain, like flour mills. This is actually kind of important to them, right? Because I have got flour from Bob's Red Mill, right, which is in Oregon, but it's a premium brand. I have opened up recently bags of flour that were infested with bugs, so it's a potential real value added, but maybe with a smaller unit, we'll see. And then your top tier distiller supply companies, this is probably the number one target right off the bat, because the problem with geosmin is an acute problem that, frankly, and I asked this to a master distiller, is what keeps them up at night. So it has many advantages. We already talked about those. Here's some things about the addressable market. How many facilities there are in the U.S. This is just North America. It's U.S., Canada. You're talking about a lot of facilities, right? Now you're talking about how many tons per day, how many units would be required by each of these facilities, and you can see how many units the total market potential is. That's just for North America. North America is a really big grain supplier, but Brazil and South America is very high, right? Asia, Southeast Asia, all of Asia is huge. And when you go to Central Europe, big grain basket, right? But you can see that the potential for this system is absolutely enormous. Now, what would a 100-ton per day unit cost? What's the target price? The target price is about $500,000. That's based on what it would cost to build it and margins that you want to protect. It might be more than that. If it's a smaller unit, maybe it'd be less than that, but then you'll need more of them. So we're talking about as your total addressable market, 30 billion, 60 billion, it depends, especially if the system becomes the standard that's required. It also depends on how often is USDA actually helping the farmer or the granary with half of the cost of the unit to get it in, because it's such a critical need. So the total addressable market is very large, right? What percentage can clear grain capture? Because this is patented technology, and because it is so vastly different from the competition, clear grain could theoretically capture a very large percentage of this market. That doesn't mean it's realistic. And how long will it take is unknown. That's really an unknown. It's a huge variable. It's one of the big risks, right? How fast can you get this going? What will the acceptance rate be? Is there any pushback from regulators like the EPA with emissions and that sort of stuff? These are all questions that need to be answered, but they are in process of being investigated at this time. As far as production, I don't think that production of these units will ever be the issue. These are a fairly simple mechanical system. It's a couple of vacuum chambers, a couple of vacuum pumps, some piping, some gas generators, and some monitoring equipment. Maybe a exhaust scrubber. Not that difficult, right? So the production of the equipment itself will not be an issue. Sales is going to be, this will be one of the easiest systems to sell that I've ever seen in my entire career, because when you can show a customer ROI at this kind of scale, when you can improve production rate by such a vast amount, and when you can get all these other bonus benefits just because it just works that way, sales is really not going to be the bottleneck. I know maybe this is a longer video than what you were expecting, and perhaps I won't even be able to upload it. But you can see how exciting this opportunity is. This is not just another Me Too. It's not a new piece of software. It's not reinventing a silicon chip, right? Which is super technical and takes huge amounts of capital to produce. This is a simple idea that has huge impact, can actually move the needle on the whole supply chain, right? Including shipping. So that's why I'm so excited about it. I think that as this project goes further, every time I talk to somebody, I find another benefit that this technology will actually just provide because of the way it operates. So it just gets more and more exciting. I'm hoping that you'll join my journey or help me in my journey, because it's going to be an exciting ride. I'm absolutely dedicated to this company, this product, this process, and there will be more things that come up. The more people I talk to, the more things that come up. So thanks very much for tuning in, and I hope to hear from you again sometime soon.